Good morning. Welcome to the grand round today. And it's by the Department of Biostatistics and Health Informatics. And they've chosen a very important topic, propensity score matching and decision tree as an alternative to randomization and regression analysis. And as we all know, whenever manuscripts are submitted, more and more journals are asking for this statistical method to have been applied to the data. And so I think it's a very important and relevant topic to take up. Dr. Prabhakar.
Thank you, sir. And again, welcome you all to this CGR that is going to be presented by Department of Biostatistics and Health Informatics. CGR topic is propensity score matching and decision tree as an alternative to randomization and regression analysis. This topic is selected because since last 4-5 years, especially non-randomized studies, when presenting the research papers for the publication, reviewer usually asks to apply the propensity score matching so that actual effect of the treatment can be presented with respect to outcome. Similarly, artificial intelligence become very popular since last recent years, and decision tree, that is the almost similar type of the method of the regression analysis, although there is a little bit difference. So decision tree finding is useful in the artificial intelligence. So all these things we are going to discuss in this CGR using numerical data. And so overall, this presentation we have divided into two sections. First is the as case 1 and case 2. So in the first part, we will discuss propensity score matching and its advantage, disadvantage comparison with randomization. Similarly, in the second section, we will discuss the application of decision tree and how it is different with regression analysis. So for the case 1, I request my PhD student Biswas Kapoor to present next few slides.
Thank you, sir. In clinical research, the reference method to evaluate the treatment benefits without bias is known as randomized clinical trial. In randomized clinical trials, there is a set guideline, including patients should be randomly allocated between the treatment groups. Randomized clinical trials represents the gold standard of the evidence-based medicine. Although sometimes they may not always be feasible or ethical. For example, critically sick patients are often assigned to standard treatment, while less critical patients are often treated by usual methods. The researchers have to be alternatively depend on observational studies or non-randomized clinical trials. In non-randomized clinical trials, there may be inequality in baseline characteristics as well as unknown confounding variables. The obtaining reliable results from non-randomized studies requires the elimination of potential influences of the confounding factors, as any estimated association between treatment and outcome can be biased because of the imbalance in the baseline covariates or in the study groups. A common way to attempt to adjust the potential bias using the multivariate regression models. However, a few of statistical methods exist that are capable of identifying and reducing the impact of confounding factors. But these methods come into picture at the time of data analysis. Among them, stratification, adjustment, and propensity score matching are most popular methods. Now, at the time of patient allocation, if the patients are randomly allocated to either groups, then this is known as randomized clinical trial. And in this case, we can perform our statistical analysis as per the standard protocol. But in case we fail to randomly allocate the patients to either groups at the time of patient allocation, we can use some statistical methods at the time of data analysis. These methods are stratification, adjustment, and propensity score matching. Propensity score matching, it is an individual probability of receiving the treatment of interest on the basis of the given observed baseline covariates for a given study outcome. Propensity score ranges between 0 and 1. Austin in 2011 reported that highest accuracy can be obtained with 1-to-1 propensity score matching. When tolerance limit of the propensity score matching is set to be 0, exact matching are presented. In case tolerance is set to be other than 0, example 0.1, pairs are matched despite with a variation of 0.1 in the propensity score between the treatment and the control group. We are here to discuss about the application of propensity score matching, its advantages and disadvantages as compared to randomization. We have taken here a problem in which our trial was conducted to evaluate the risk of mortality in patients suffering from myocardial infarction within 30 days under rapid administration of a newer clot busting drug, that is treatment A, against a standard therapy, treatment B. The patient's allocation between the two groups were purely on the basis of non-randomized process. 400 patients received treatment A, while other 400 received treatment B. A total of 800 patients were recruited in the study. Our objective here is to evaluate the effect of the treatment on patient outcomes. we have taken a hospital-based, non-randomized clinical trial. This data set was borrowed from IBM SPSS 23 example files. In this analysis, we have taken the variables as age in years, gender, angina, abnormal blood pressure, smoking, obesity, diabetes, high cholesterol, and our outcome variable as patient outcome, survivor or non-survivor. The effect size was calculated for proportion using the Cohen's effect size and for mean from the difference in means between the two independent groups. The range of effect size between the two groups are categorized as less than 0.2 as negligible, 0.2 to 0.49 as small, 0.5 to 0.79 as medium, and more than 0.8 as large. The effect size can also be estimated from the link given below. To detect 10% difference in proportion of mortality between the two groups at minimum 92-sided 95% confidence interval and 80% power of the study, we required 388 sample size in each of the two groups. The continuous variables are presented as mean plus minus standard deviation, whereas the categorical variables as frequency and percentage. Independent sample t-test or two proportion z-test or chi-square test were used to compare the means and proportions respectively between the two groups. Binary logistic regression analysis was used to assess the predictors of the outcome. Propensity score matching was used to match the variables between the two groups. A p-value of less than 0.05 was considered as statistically significant. Statistical package for social sciences version 26, that is SPSS 26, and MedCal version 20 were used for this data analysis. Now I request Prabhakar sir for the result section.
Overall, in this study, 800 patients were included. These patients were allocated between treatment A and treatment B basis of purely non-random process. So between treatment A and treatment B, when we compared the demographic variable and clinical variables as well as outcome, so here except age and outcome means non-surviving and mortality, that was higher in the significantly higher in treatment B as compared to treatment A. Rest variable were statistically equal between two groups. Here mortality is our outcome variable, so from the independent side age was significantly higher in treatment B as compared to treatment A. So definitely here directly we can't make the conclusion that in the treatment B around 10% mortality, 10.5% mortality is higher as compared to treatment A, because age is age is varying between two treatment group. Interesting result is coming for the age because it is coming significant difference between two treatment group, but actual difference in age is around 2.5 years. And so here additionally I use the effect size because advantage of the effect size is it is not affected by sample size, but p value is severely affected by sample size is overestimated or underestimated, accordingly significant or non-significant result is presented. So here because sample size is good, 400 in each of the two groups, so why result is coming significant, age was significantly higher showing in treatment B as compared to treatment A. But according to effect size, our difference is close to the negligible because 0.2 onward is considered small effect size. So less than, so it is a close to 0.2 means 0.23 it is there. But now I am going to discuss what are the conventional method to analyze such data. Presently our conventional method to analyze the data is regression analysis. And when we use the regression analysis, so see here in the left side univariable analysis is presented, and here outcome is our outcome, non-survival is our event. So here we can see in the treatment B there is a more than 10% higher mortality. Similarly, abnormal blood pressure, smoking and obesity are showing risk factor for the mortality, as well as in non-survivor age was significantly higher. So out of 8 variables that I have taken in this study, these 5 variables are showing statistically different between survival and non-survivor. That is the outcome of interest in this study. And usual when we use multivariable analysis, and out of these 5 variables, 4 are coming significant, 4 are coming significant independent predictors of the outcome. But one variable, that is blood pressure, that was excluded from the group of the independent predictors. Reason is that blood pressure was highly correlated with, highly associated with obesity. So multivariable analysis, in the regression analysis there is a limitation also to all the variable we cannot put as independent predictors. Reason being that if between two independent variables they are highly correlated or associated to each other, out of them one will be excluded from the model. So this type of problem we chase during the analysis of the multivariate. So here, despite it might be blood pressure has impact on the mortality, but it is not showing as a independent predictors in the regression analysis. If we can go for alternative method, that is the propensity score matching, or it is a additional method, we can say additional method with regression analysis. So here in the propensity score matching, this is our table 1. Then this table 1 now presented is like this, and here we can see that the age has been exact match between treatment A and treatment B. And once variable exact match age, now effect size become 0 and p value is 1, means 0.999, one we don't write, so written 0.999. So it is showing exact matching age, and the rest variable are also become, also are statistically insignificant between two treatment groups. Now because all the variables are statistically equally distributed between two treatment group, now here we can make the statement that in the treatment B there is a around 9% higher mortality as compared to treatment A. So usually reviewer asks, you have to present first all the variable. If all the variable are matched, then what is the proportion of the mortality in this treatment in another treatment group. But this is not exact matching. This is the almost they are statistically equal label matching. And here 9% higher mortality was found in treatment B as compared to treatment A. And it is also statistically significant, but statistically significant, already I told, it is severely affected by our size of the sample. If sample size is small, same difference become insignificant. But effect size is 0.175, who is showing that although difference is 9%, but it is according to clinical difference, it is a close to negligible. Now, when another method is, another way of presentation is that if we can exact match the variable between two groups, treatment A and treatment B. Now, after exact matching of all these variables, it means nobody can claim that this variable was higher because mortality was showing higher in this group. Now here age and all other variable are exact match. And although during the procedure of exact matching, we lost 389 cases in each of the two treatment group. So this is the one type of disadvantage of the propensity score matching also. During the process, we lost many important cases. And here, because all variable are exact match there, and it is showing that around 9% exact 9% mortality is higher in treatment B as compared to treatment A. And this is our absolute clinical difference, 0.183 effect size. Effect size is focused to the clinical difference, and 0.173, this is the p-value for focus on statistically different. So here we can additionally use effect size and can present that our effect size is 0.183, although it is a close to negligible, it is a negligible range, but still it is something. So 9% difference in treatment B as compared to treatment A. So this table, this part, and just before that, this can be presented as an application of the propensity score matching with available usual methods. So simultaneously we can use other method, and additionally we can present these methods. So exact absolute effect of the treatment can be presented, because here all variable are equally distributed in between two groups. Now analysis showed that during the matching we have lost many important cases and sample size was reduced, and due to this statistically significant and further result generalization could be affected, which is a major disadvantage of the PSM also. The randomization process assured that RCTs are balanced, randomized clinical trial are balanced both on observed as well as unobserved factors, mean known and unknown factors. Propensity score methods can only account for known factors and major confounders in observational data. This is the one of the limitation of the propensity score matching over randomization. Propensity score matching cannot replace the importance of the randomization, but are a good alternative for analyzing non-randomized trial. So this was the first section, yeah, another thing, one term is used, case control matching. So propensity score matching and case control matching both are exactly same if we are doing the exact matching, because see, this is the example here, 6 variable as a independent and 6 variable are used to match between class bursting drugs, means treatment A and treatment B. So here for all variable, using all these variables, first we calculate a propensity score, and then we decide at which margin of error we need to match the variable. Even if we are taking zero tolerance, it means this is the exact matching. It means same propensity score, matching patient from the treatment will be matched with same propensity score patient with control group or another group. So this is the procedure. But in case suppose we are putting match tolerance 0.2, it means despite 0.2 propensity score varying between treatment and control group, any patient suppose in the treatment A it is a propensity score is 0.56, it means another control group if it will be plus minus 0.2 of this propensity, that will also consider match with this particular case. But in the case control there is a sometimes when individual variables intensity we want to decide. See, gender, obesity, diabetes, blood pressure and smoking, these are the categorical variables. They are always exact matching, cannot change the margin. But age, this is the continuous variable. For this variable intensity we can, or margin of error we can decide at which we want to match. So like age we want to match plus minus 2, if age will be vary, still we will consider as a match case. Then in place of first, it is the order, it is the here order age is first, here this 0 value will be replaced by 2. So by these procedures we can use the case control matching, but in case it is rarely used. But see here when we are talking about the matching, whether it is a treatment control, case control, don't confuse with the wording. It is match between two groups, either it is a case control or observational data, anything. So accordingly we can match. So it concept is it will be matched between two groups despite the study design. Now for the case 2, again I request my student to present Vishwas Kapoor to present next few slides.
Decision tree analysis. Decision tree is one of the most used practical approaches for supervised learning to solve both the regression and classification tasks. It is useful more into practical applications for complex datasets. It is a tree structured classifier with types of nodes. It is used for regression problems where we are trying to predict something with possible answers, such as the factors responsible for a disease or mortality. It breaks down the data set into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. The result is a tree with decision nodes and leaf nodes. Decision tree analysis presents 4 methods. Out of them, the most popular are classification and regression tree, also known as CART analysis, and chi-square automatic interaction detection, that is CHAID. In CART analysis, the variables are classified into 2 groups, whereas CHAID, the variables are classified into 3 or more groups. Outcome as well as the independent variables both could be quantitative or categorical variables. CART method uses chi-square test or independent sample t-test whereas Chad uses the chi-square test or one-way ANOVA test with Bonferroni correction. We are here to discuss about the application of decision tree analysis, its advantages, disadvantages over usual regression analysis. This is the same problem we have taken in case 1, so no need to discuss it. This is the same data borrowed from the SPSS 23 example files. The proportion and for mean, the effect size was calculated as same in case 1. We have taken the same sample size. In statistical analysis, we have added the decision tree, CART and CHAD analysis were used to present the predictive and descriptive analysis over corresponding regression methods.
So this is the table 1 that was same discussed in the case 1 also. So no need to discuss again. And here see age was significantly different between two treatment groups. So during the usual conventional regression analysis, so this was the univariate and univariable and multivariable analysis that is presented here. And here 4 variables are coming as independent predictors of the outcome, that is the mortality or non-survival of the patient. So this is the usual analysis of the regression that we are doing during the analysis of the non-randomized data to find out the to present the effect of the treatment after adjusting all other variables on the outcome. Now I am going to discuss the CART method and CHAD method. So first, classification and regression tree. This is the same data when I analyze by the classification and regression tree. So here, see in the node 0, this is the node 0. Always first, this box is called node. So node 0 here, non-survival is 42.5% in our data set. Out of 800, 340 mortality, so 42.5% was non-survival. And when this was this was presented between treatment A and treatment B. So in treatment A it is a 37.2%, and in treatment B mortality was 47.8%. Now treatment B has higher mortality as compared to treatment A, already evaluated by other methods and previous analysis. Now what is doing by the decision tree means here it is method is classification and regression tree. So this method used to classify the data as well as just like application of the regression. So it is the CART analysis. Further, this treatment A, although there was less mortality as compared to treatment B, so here by the using discriminant analysis, here it is presenting that below 66.5 years and more than 66.5 years, here less than 66.5 years mortality was 29.9%, but in the 66.5 or more years it was mortality was 59.6 years. It means if age was this or more than this, then it was automatically showing the predictors. And here the age which was less than 66.5 years, here in the further age was categorized between two groups, less than 57 are equal to 57.5 years and greater than 57.5 years. So further mortality was showing here was 22 and it is a 39. Similarly, here in treatment B, it is a presented that in this group, blood pressure in the abnormal group 57% mortality, normal blood pressure group 40% mortality. So further abnormal cholesterol was predictor, and in the cholesterol you can see that. Okay, so further in the abnormal group, cholesterol normal and high cholesterol level are data divided, and in the high cholesterol level mortality was 65.8% as compared to the normal cholesterol level where it was 50%. So here for the treatment predictors was predictors was 66.5 years or more age group and if for lower age group whatever mortality is reported, that predictor it means within the group less than 57 or protective and more than 57.5 to 66.5, that was the risk as compared to this group. Similarly, treatment group B high cholesterol level with abnormal blood pressure, and if taking his treatment B, a patient taking treatment B had abnormal blood pressure as well as high cholesterol, they were under they have chances of high mortality. So because it is a cart analysis, it is divide data into only two parts. It cannot divide the data in more than two groups. And for the more than two groups, and there are some other advantage also. Disadvantage the next method be used chi-square automatic interaction and detection method, and the same data are plotted by this method, and here up to there node 0, treatment A and treatment B. This is the just like of the cart method. And but here in the treatment A, further age was divided into three groups. Age was divided into three groups. It means less than 53, 53 to 66, and more than 66. So more than 66, it is showing high mortality, low mortality, but it is the middle range of the mortality proportion. So in this group, blood pressure, here blood pressure is showing the predictors. Although there is in the abnormal group mortality is coming 26.7%, but normal it is showing 40%. So this is the data, I can't do anything about that. But here in the treatment group, here blood pressure, treatment group, here blood pressure, abnormal group there is a higher mortality as compared to normal, and in the abnormal further it was divided in high cholesterol and normal cholesterol. So it is showing in the treatment B high cholesterol and abnormal blood pressure like cart 1, and here in the treatment A additionally blood pressure means normal blood pressure, and this age group and this group as is showing as a risk factor for the treatment A for the mortality, whatever mortality is coming, although mortality is as compared to treatment B less reported in treatment A. Now four variables, that is age, treatment, obesity and smoking were identified as independent factors of the non-survivor. There is a separate distribution of identified risk factor in regression analysis and decision tree because of farmer identify as a whole variable. मतलब regression identify as a whole variable of the predictors, whereas later identify risk factor for a group only. Regression analysis should be used to identify factors as a whole, whereas for depth analysis, further decision tree would be preferred. Now review of literature, I have taken 3-4 review because during the literature review of literature I found many literature, but out of them many were not looking reliable, so I have taken 3-4 literature that is most number of times cited. So here first I have taken Austin PC in 2011. This citation was 7505. Author mentioned the most common implementation of propensity score matching is one-to-one or pair matching, in which pairs of treated and untreated subjects are formed, such that matched subjects have similar value of the propensity score. Although one-to-one matching appears to be the most common approach to propensity score matching, other approaches can be used. Another was this is cited by 61 for the propensity score matching, and author mentioned that propensity score method will remain important design and analytical tools to estimate effect of treatment from observational data. They means propensity score should be considered complementary tools and not replacement of the conventional regression adjustment. In fact, when appropriate propensity score methods should be used in combination with other model-based regression techniques. So this author suggested that we have to use regression analysis in even non-randomized studies, and additionally we can use propensity score matching. This was the regarding decision tree. This author mentioned that classification is one of the most important technique in machine learning. In classification problem, logistic regression and decision tree are two different algorithms in supervised learning. The result received from experiments showed that cart decision tree perform much better in data set with more attributes and slight imbalanced data distribution, because in the decision tree we have no required of the normalized data, although we have required higher sample size. So here last, this was the review of literature when it is cited by 3653, and it is showing that why we need to report the effect size. Although this is a debate with the topic, but I have used the effect size. So I am going to present the effect size is main finding of the quantitative study, while a p-value can inform the reader whether an effect exists. The p-value will not be revealed the size of the effect. In reporting and interpreting the studies, both the substantial significance, effect size, and statistical significance p-value are essential to result to be reported. And the summary was of this article that effect size help readers understand the magnitude of the difference found, whereas statistical significance examines whether the findings are likely to be due to chance. Both are essential for reader to understand the full impact of your work. Report both in the abstract and result section. So this author suggested that simultaneously with the p-value we need to report the effect size also, especially in the major finding, so that if there is a under or overestimated of the sample size, that impact can be removed and actual detected difference can be presented, and so that avoid the misleading of the any result. Effect size can be presented especially for the main findings. So thank you.